Today we're going to look at composition of functions. There are two ways to write composition of functions. One is f, little circle g, and then x in parentheses. The other is f parentheses g parentheses x. Both of these are f of g of x. So you read them in order, f of g of x. A couple things to keep in mind. It is not called fog. It is also not f times g. It is f of g of x. Just in case you were curious, it's definitely not called fog. And are you ready for this next transition? Yep, really truly, it is not f times g. They danced around to show you that they were not. Okay, to find the composition of functions, if any of you have seen the movie Inception, Inception is like dreams within dreams within dreams. This is the inception of math. It's functions within functions. So f of g of x means that we are going to take the g function and put it entirely inside the f function. I'm going to use colors to help us out. We're going to have the f function be blue and the g function be purple. And I want to show you the different ways to write this as well. So f of g of x can also be written as f of g of x. And by writing it in colors like that, do you see how the purple one is inside the blue one? Yep. So g is inside the f function. Since you see f first, I'm going to write the f function, but I'm going to basically take this x out and leave a space. So f of x is something minus 2. We are going to put the g of x function inside that something. So the 4x plus 7 goes inside that space. So the f function is something minus 2. We are putting that g function in place of that x. So 4x plus 7 and then minus 2. Is there anything being multiplied in front of the parentheses? No, so we don't need to distribute. So really this is just 4x plus 7 minus 2. Positive 7 minus 2. What is positive 7 minus 2?
5.
So 4x plus 5 is our final answer. Now we're going to do this backwards. We are going to do g of f of x. This time, we're putting the blue one into the purple one. Since you see g written first, I'm going to start with the g function. The g function is 4 times something plus 7. Does everyone see how I basically took a skeleton of that g function? 4 times something plus 7. I took the x out and left a blank in its space. Inside that blank, I am going to put the f function. Once I have this written, do we need to distribute? Yep. 4 times x is 4x. 4 times negative 2 is negative 8. And then we have the plus 7. Go back. Go back. Go. Negative 8 plus 7 is negative 1, so our final answer is 4x minus 1. G of f of x is 4x minus 1. Now notice, we did f of g of x and then g of f of x. We did them reversed. Did we get the same answer? No. So f of g of x and g of f of x are not the same thing. The order matters. In C, they want us to do f of g of 5. It can also be written this way, f of g of 5. We are going to take 5, plug it into the g function, get an answer, plug that answer into the f function. When it's written in this way, you start in the middle with this 5, plug the 5 into the g function, get your answer, and then plug that answer into the f function to get your final answer. So if we plug 5 into the g function, we would do 4 times 5 plus 7. What is 4 times 5? 20 plus 7? 27. Then we take 27 and plug it into the f function. 27 minus 2 gives us 25. So f of g of 5 is 25. There is a shortcut. If you already know that f of g of x is 4x minus 5, and now you want to do f of g of 5, you can find that f of g of function and plug 5 into it. 4 times 5 is 20, 20 plus 5 is 25. But you don't always have that, so I want you to know how to do this even if you don't have f of g of or g of f of. So in D, we are doing g of f of negative 1. I'm going to write it like this, g of f of negative 1. It means we need to take negative 1, plug it into the f function. So negative 1 minus 2, what does that give us? Negative 3. We plug negative 3, the answer, into the g function. So 4 times negative 3 plus 7. Negative 12 plus 7 is negative 5. In example 3, it asks true or false. If this is our f of x function, x plus 1, and our g function is 6x, is f of g of x the same as g of f of x? And the only way to do this is to do f of g of x and then do g of f of x and compare them. So I would like you on your own. On the left side, do f of g of x. On the right side, do g of f of x, and then we'll compare our answers. So pause the video, try this on your own. Okay, so I'm going to, I guess I'm changing up my colors a little bit, but that's okay. No, come back. It's really annoying. Okay, so I'm going to have F be purple this time and G be blue. So for F of G of X, I'm taking the F function and doing something plus 1. I need to put the G function into that, so I'm putting 6x into that. I don't have to distribute, so my answer is 6x plus 1. F of G of X is 6x plus 1. For G of f of x, I'm taking the G function, which is 6 times something, and I'm putting the f function inside that. This time I do have to distribute, and I get 6x plus 6. Now compare those. 6x plus 1, 6x plus 6. Are they the same? No. They are not the same, so the answer to this is false. This assignment, number 1, number 2, and number 3 each have problems A through D, so there's really 12 problems here. So I'm going to cross off number 2. So you need to do number 1, A through D, and number 3, A through D. That way you're doing 8 problems. That should be enough practice. If you can do 8 problems really, really well, you've had enough practice on this, and we can call that good.